So I'd like to welcome the other members of the panel up. Ian Dickinson, who will be chairing it, Pete Stevens, and Tom Hill. Sorry, Tom, from Bytemark. So, okay, the microphone runners, if we could have one of the microphones for Ian to have. Okay, if you want to use the lectern one, then you can pass. Okay, so on you go.
Hello, everybody. Hopefully we can augment what's being covered there and cover a few different things. I'll use half the time for my questions, and then you guys can chip in. Hopefully you'll have lots of them. So the first question that comes to mind for me is, other than the raw v4 address cost and complexity, are there any real good commercial drivers to convince other people that this is the right thing to do?
Is this on? Good, okay. Certainly we started with the v4 cost and then realised actually it's the complexity that really makes the difference. Beyond that, I can't think of a particularly obvious massive advantage to v6 over v4 other than stripping out complexity would be the main one for me.
Yeah, complexity in the infrastructure is a big part of it, and this is especially a big deal if you're thinking from an application and server perspective, because it's network links are easy to draw on a map, but then you have microservices and a customer that's run hundreds of services, and all of these services talk to each other over the network. And you have dual stack all over those various inter-microservice dependencies, and you have no control over what talks to which service over which protocol. Then the complexity gets so enormous that you have no idea if you have an IPv6 failure what actually ends up failing. So the complexity is a really big thing, but we also see that because of microservices, because of scalability, when you have customers that suddenly want to run up 500 VMs over 10 minutes, and I say, oh wait, my /24 is not big enough anymore, right? And with IPv6, you never ever get that problem because every LAN is endless or infinite. So yeah, it's another thing.
I probably don't entirely agree, and I say this as someone who has a good chunk of IPv6-only VLANs that don't involve any IPv4 numbering at all, and I've talked about this in the past, and that's great where we use these things internally. The complexity of adding more middle boxes or adding more middle box actions, I think at the moment, certainly with unmanaged hosting, where you're just selling a pure IPv4 and IPv6 connectivity and you don't know what people are doing with those machines, adding all of that extra complexity would be quite a headache, in the sense that you don't have direct visibility of the servers, you're not able to manage them. On a managed side, potentially I can see this, but I think we are actually missing an extremely obvious use case and commercial use case for dropping IPv4 and going IPv6 only, particularly for people that aren't necessarily network engineers, people that work in web design or user interface design, or they're in startups and things like this, and the one thing they don't want is a headache with their hosting.
So is there anything that would drive you to really push harder in there? What's the thing that breaks the logjam in that area for you?
I think IPv4 has to break first, really. I mean, it has to be a lower grade connectivity option than IPv6, which potentially will happen in the future, but at the moment I don't believe that's the case.
So you're relying on the eyeball networks to destroy their quality with carrier grade NAT, basically?
Yeah, stop making it work. No, but in all seriousness, there are people out there that control Quad A records that don't give a hoot about this at all. There's thousands of them. And I run into them all the time, and they're like, oh, IPv6, that's just a bit too common. Oh, I don't want to learn that. But my IPv4's working, it's fine. And certainly I can understand the basis if you're working on big managed scale projects and actually taking, for the suggestions that have been, and the presentations that we've seen, perfectly sensible, perfectly reasonable, but where you're not and you're just providing infrastructure to someone, making that as pure and as fast and as reliable as possible is very important at the moment, and at this point it still is reliable.
So tying into that in terms of complexity and who the customer is in a lot of ways is a two-part question is, do you find that the customers are exposed to this in any way and they're ready for this? Do they need more training, and are they fit for purpose really and as comfortable as they are with V4? And similarly with your own internal staff, help desk and other things, do you find that you have to do a certain amount of push to get them there, or it's no different?
So in our case, it varies a bit from customer to customer. Some customers are very hands-off and say, you fix the service, and we provide journalists that want to type articles into a web interface. If the web interface works, we're happy. We don't care how it's done. Then you have some customers that are more involved. They might be used to hard-coding IPv4 addresses in their config files. And we tell them, use a host name instead, or this IPv6 address, and that's okay, it's fine. And if we have a customer that really wants to do something, has an app that just needs IPv4, then we have the option of doing a CLAT on the server, just like you do on the phone, like Nick was talking about, which actually provides a virtual IPv4 interface, but still lets the rest of the infrastructure remain IPv4 only. And in that case, we have never had an issue with that, because then it just looks like IPv4 to them.
So a bunch of our customers don't know they're running V6 only. We did one over the weekend. They do analog photographs, photography with chemistry. Apparently you can still do that. Yeah, we moved them over. They're running a managed WordPress shop. It's V6 only, and they have no idea. The only thing they know is we host Raspberry Pi, and that's a big WordPress site, and they wanted the same thing that they had. And so that was useful. So yeah, actually the big problem are the technical and semi-technical customers who know this doesn't work, and therefore they can't possibly buy it. And the evidence of it working is not enough to persuade them. I quite often use the phrase reality disagrees, but it's amazing how resistant some people can be.
Yeah, I mean, Bytemark are quite a clever bunch internally. We've got a lot of very clueful people, so we don't necessarily have any particular issues with staff or anything like that. We don't necessarily have any particular issues with customers as such, but it's the customers that we talk to. Quite often, you can go and buy stuff from the website, spin it up, and never talk to us about it. And that's, these things just have to work as they are. On the sense that, I'm not against IPv6 only hosting. I'm not against the premise of sneaking it in there and just not telling anyone. Honestly, it wouldn't be a bad idea at all. But I think the one thing I've got to balance this against is the fact that there are, at the moment, some particularly, interesting setups that may be on routers that aren't the ones that I currently own. I've got to add in extra boxes, or I've got to start using different devices to do this. Those may not have the same forwarding performance as what I'm currently using for IPv4, which is just working, and I'm fortunate enough that I still have enough IPv4 addresses for a good deal, longer.
You brag. So,
lucky boy, eh?
Well, I mean, and that ties into pretty much when does peak V4 happen? When do we hit the point where whatever capacity you have for doing V4 traffic, however it's performed, you don't need to invest any more in capacity upgrade there because it's staying stable and V6 has taken over. You can tell I'm an idealist. So what's the thing there where you actually say, no, it's worth doing now? I mean, you've already got a path if you've already done this.
I mean, it's pretty obvious. I mean, next time you do a hardware refresh, you start looking at these features and making sure that they're available in the hardware that you're going to buy next time round. I mean, Tor used the example of the ASR and the CSR config. That's great. It doesn't currently work in my aggregation routers, which are a different model. But at some point, we could swap those out, replace those out. Traffic there's plenty of constraints and reasons why that would happen. And at that point, you'd certainly factor in these options to make them, viable, as it were.
Yeah, I mean, one of the classic scenarios here is how long do we have to run these transitions for, of whatever flavour we do? So when do you think that is? Do you think there will ever be a point of the true turn-off across the board, or where it's become such a long tail that you significantly care about it less?
I would probably say long term. I have no idea how many decades. But the main point for me then is, or for us, is to make sure that these, as in the backward compatibility systems, they're not kind of creeping in through the whole infrastructure, right? We want them sitting there nicely on the side, independent from everything else, so that, okay, if IPv4 traffic is 5%, well, they can still sit there. They use electricity, and that's it. We don't need to scale them up because traffic is going down, right? We do not want to have IPv4 compatibility through the whole infrastructure to support that amount of traffic, because then you have a problem with the economics of the added complexity. But as long as they're sitting nicely on the side, independent from the main infrastructure, they can sit there for as long as they need to without any real costs.
Well, I mean, I guess I'd start by having a quick look at Daka, right? Daka uses NAT and an overlay network. Why doesn't Daka use public v4 addresses? And the reason is really simple. They cost more than containers. You know, if you tried to build a Docker infrastructure with public IPv4 addresses, you'd very quickly exhaust the entire IPv4 space for individual providers. You know, the reality is the number of addressable things is going up really quickly. And you know, EE, we're talking, what, 20 million plus devices, 100 million plus devices, RFC19 space isn't big enough. So ultimately, we're going to have 4 billion IPv4 addresses sat there that provide some connectivity to the other 4 billion things on there, and at some point there's going to be another network that has more devices than that. And then you have to start asking existential questions like which one of those is really the internet after all. So, you know, I think there'll be a v4 compatibility layer for a very, very long time, and there'll be some people who have got v4 allocations that they will never ever deploy v6, and they will never have to because there will be a translation layer. And that will probably, you know, sit there basically indefinitely until eventually someone turns around and says, I've come up with a new service. It's really easy to implement on v6. It just doesn't work on v4. 80% of people have got v6. The other 20% can either get v6 or get stuffed. And that point will come in exactly the same way that web developers had this with Internet Explorer 6 support. You know, Windows XP came out in 2001. It was discontinued. You're not supposed to buy it anymore. Every corporate application has to run Internet Explorer 6. It goes on and on and on. Web developers are screaming, going mad. Why can't we get rid of IE6 support? Why can't we make it go away? And then one day, suddenly it turns out there's no security patches for Windows XP. It's got a security hole. And the web developers just turned around en masse and said, look, it's insecure. We're not supporting it. Upgrade to a secure browser. You can no longer use our secure stuff. And simultaneously, over the course of a very short time period, everyone just stopped supporting IE6, and then people who were reliant on IE6 on the desktop suddenly just had to upgrade because nothing worked anymore. So there's going to be a period where we're going to gradually spread out IPv6, and the support will keep growing, and more people will have it. And then one day, somebody somewhere is going to come up with an application that breaks ranks, and it might be something like computer gaming, which relies on end-to-end connectivity actually working, rather than relaying everything through central servers or something along those lines. And once that happens, suddenly everyone will fall over because no one wants to be on the old network that's missing the shiny new feature.
I have a slightly more cynical alternative, which is not that there's going to be a killer application for IPv6, but more such that the IPv4 network across the globe will become such a cesspool of miscreant, mischievous behaviour. IPv6 probably, hopefully, won't have quite as much of it. But if it gets to that point, there'll be people that just sit there and say, right, we're turning off our IPv4 if you can't connect to us over IPv6. Bye. Gone.
So you think that's a cynical viewpoint? That sounds very idealistic about how clean the v6 internet is going to be.
It's not bad at the moment.
It's certainly not entirely clean from my view.
No, it isn't.
So, I mean, one of the things about that trade-off that seems to be a fun one to me is, okay, you're doing a translation side. The eyeball ISPs are doing a translation side. Everybody's paying for this. Who's going to move first to turn it off and save themselves the money? So, do you think you'll end up regretting having spent anything on doing the translation because you moved at a certain time, or just say, don't care, it's cheap enough and our customers work?
I think Pete's probably right about the sort of the 80-20 sort of mix when it gets to that point. It's going to be someone that just says, right, you need IPv6 now if you want to connect to us. And I think potentially a lot of the embedded CDNs are going to be the first people to start wanting to just get rid of IPv4 completely. Whether or not they would remove IPv4 entirely to avoid a catch-all somewhere in the world, just one box somewhere in San Jose that's hosting the whole of the IPv4 internet for them, possibly. Maybe they'll keep that on till the cockroaches or any of the things left. But at some point, it just becomes silly to power up devices that are doing a job for no return on investment. So it's going to take a long time.
So, and back to the new V6 app that drives a thing. Do you see any specific use cases that you haven't covered that drive it in the hosting space? Are there any particular things coming relating to storage or other things hosting specific that are actually going to drive this for cost or simplicity?
Yeah, containers. Containers chew through address space like nobody's business. So the Sugar CRM install that we built out, at the moment we're doing a complete customer in a container. So we need 2 containers per end customer, which is going to chew through something like 500 V6 addresses to 500 to 1,000 V6 addresses per host. If we'd done it as a proper microservices architecture, it'd actually chew through nearly 10 addresses per customer. Which would up that by another factor of 10. And you start talking 10,000, 50,000 addresses on a single box. And this is an architecture that's going to break private address space. And it's all going to fall apart. And if you start looking at some of the workarounds that, particularly Daka uses, so if you want to connect 2 Docker machines on 2 different VMs, you've got a whole choice of different overlay networks you can use, from Flannel to Weave and so on. And there's a great benchmark of Weave.net, which demonstrates that if you've got some 20-core machines with some 10 gigabit network connectivity between them, and you're prepared to donate virtually all of your CPU to making packets go as fast as possible, you can get nearly 200 megasecond of traffic between them, which is, 98% of your bandwidth is thrown away and most of your CPU is thrown away. If you run a major hosting provider and your job is to sell CPU to people, this probably looks like a brilliant way to charge people for doing NAF all, but to be honest, I'd like it to be a bit more efficient. So yeah, containers, it's going to chew address space like nobody's business.
Fully agreed.
I mean, it seems to be one of the keen things at the moment. I always question whether that degree of state suggests that it's going to be a successful long-term approach, but it's better without having true stateful state. Let's have a look.
You want to take some questions?
Yes, let's... sorry, I missed the 10. Questions from the room, I think, is a good time. Keith?
I have one from the IRC room, which is, do you see the big IPv4 payload not fitting an IPv6 packet problem?
I guess that's for me. Well, for TCP, it's not really a problem because of MSS negotiations. The V6 server advertises a small enough MSS by default to cause the V4 client to not send too large packets back for UDP and other protocols. That's something you have to think about. So either you need to fragment in the V6 network, which sucks, or you can do jumbo frames in the data center network, which you probably want to do anyway. So that's the other option. So it's something that you need to think about. It didn't fit in my presentation in 20 minutes, but it's all there in the RFC.
I mean, certainly on the eyeball side, the homeland is a wild west, and it connects to the whole of the internet. PMTUD issues do exist, and I suspect all you can do is keep yourself fully MTU clean and hope that the problems never are your fault, even if your customers suffer.
Tim.
It's a question for Tori, and I guess Pete as well. In terms of volume of people that are using this, I guess for Pete, what you described is a V6-only service, whereas Tori, it's providing V4 access to V6 only. Are there big examples of users or customers that are starting to use this? I guess there could be deployments of SIT-DC that are essentially transparent, so you wouldn't know who's using it. I guess it's part of the issue there, if they don't speak to you.
So our biggest one is Raspberry Pi, which is the one we're actually allowed to talk about, which makes things much easier. But yeah, they've run a V6 back-only network, V6-only back-end network for some years with V6, V4 translation on the content nodes at the front. And we're now at the point where we could consider deploying V6-only content nodes on the front and having a subset of them running V4 because there's enough V6 traffic to justify that. I don't know if there's anyone else I can publicly disclose who's sat there running V6 on the back-end network, partly because they might not know.
Well, how familiar are you with Norwegian Media conglomerates? That's kind of the question here, because if you are familiar with them, you would recognize our media. But that's, I think, the second or largest media house in Norway, and they are with us, and they have something like 70, 80 publications, newspapers, online newspapers. They make massive use of SITDC because they make massive use of containers and microservices. So they found out that, and they are a very active customers. They are very involved in the service. So, and they see the value of doing V6 only because of their scalability needs and how they need to be able to dynamically deploy new services and new hypervisors and new everything without really involving us too much. And thus they see the value of V6 and thus they want SITDC.
And certainly on the wider view of how you get people to use this, if it's opt-in and you have to encourage them, your take-up will be low. If it's default on and just works and no one notices, your take-up will be high. And I think that applies equally to access as well as hosting. Although some... Yeah. Although the more specific enterprisey you get, the harder it is to play those games.
Okay, unless there's any more questions, I think we're well, we've got time for one more if you...
Just one more on the left.
Oh,
good.
Does the panel think that IPv4 will stand in the way of automation?
For the customer I mentioned, the media house, definitely, because they need to be able to deploy things in minutes, and if that requires us to, change the subnet prefix length on some sort of LAN, that's not going to be automatable because if it's V4 at least, it's probably going to be busy, the next adjacent subnet. So V6 is definitely an enabler for them to scale, especially automating scaling in particular.
We've actually, I spoke previously actually about some of the wins that we've got from number pools available on a particular segment, and how if you were using, if you were picking an IPv4 subnet, it would be a pain if you ever got it wrong and had to renumber, whereas a /64 is virtually endless. Just the number of devices that you can generate an IP6 address for, and off it goes, and that's great. The fun thing is that something that Pete mentioned, which was the net booting. Plenty of devices have real problems with doing net booting over v6 without any IPv4 addresses. So at the moment, unfortunately, IPv4 is propping up a good chunk of automation in terms of spinning up machines and various other things like that. So is it a hindrance? Yes. Is it a help? Also yes. But hopefully, as these things move forward, the wins that you get from IPv6 will be across the board, and you just won't need IPv4 to do any of these back-end automations at all. And that will be a lot sooner, I think, than the IPv4 going away completely.
So our managed VMs have pretty much automated provisioning. You just say, make me a managed VM, and it comes up and appears in our graphing service and backups and things like that. It doesn't support v4. You can't spin up a v4 only service. It won't work. You've got to spin up v6. So is v4 in the way? If you want to be v4 only, yeah, you have to do it all manually. That's a really good way to encourage people to adopt v6, by the way. Make the v4 path manual and the v6 one automatic.
And that's, by the way, required by the RIPE and CCS policies.
Okay, I think we're done.
Thank you to the panel.
Yeah, thank you, Ian. Thank you all.